So I want to talk about a concept that sort of hit us between the eyes when we were working on the Riverdale project, and it was because we had to reach net zero at the lowest possible incremental cost. We realized that any energy that we didn't save by making the envelope better, by reducing lighting and appliance loads, was going to increase the size of our photovoltaic array. And we knew that that was going to cost, at that time, $7 or $8 per kilowatt per year of capacity, and so we could conserve until we reached that cost. And I'll get to that in a bit in a minute. But conservation is always the very best investment, and it's indistinguishable from collection. It's got no moving parts. It's good for the life of the building. You put it in there and forget about it. Somebody can put up a 10-story building right next door and it won't perform any less well. It's by far the cheapest and most benign form of renewable energy there is. And that's true of everything. The energy that's not used is the very best. So in order to know whether you're getting close or not, or whether you've got any hope of reaching net zero energy, you've got to know how much energy you're using. You've got to know how much you're going to collect. You've got to know how much you're going to use. And so the next step is to model the preliminary design. And I would do this while it's in a very sort of sketchy form before it gets pretty and you get attracted to it in case you have to change it. We use HOT 2000 for that. Getting HOT 2000 modeling done may be problematic, and I was just talking to Rob a few minutes ago about the possibility of organizing a short course next fall for people who want to learn how to do it. How many people are interested, just to see whether it's, wow, holy mackerel, okay. Anyway, by using HOT 2000, you end up, I mean, you put every component of energy use in the house is entered into a spreadsheet, and it will spit out not only a total amount of energy consumed, but it'll also spit out what the consumption is for each component of the house. So it becomes a very useful tool to help you fine-tune and optimize. And I can't say enough about the benefits of learning to do it yourself. One of the advantages, I think, and one of the reasons that the costs for the Riverdale project were lower than, as far as I know so far, any other team in the country of the equilibrium houses, was that we did the modeling in-house ourselves, and we were able to do it over and over and keep tweaking things until we really worked the costs down. And so learning, and I'd been building R2000 houses for over 20 years, and I learned more in the process of modeling and running these iterations over and over and over than I had in the previous 20 years, as far as I can tell from today. So the way that works, I mean, we in Riverdale, we said, okay, we know it's going to cost about $7 per kilowatt hour per year for the capacity to collect the energy that we don't conserve. So we then, I mean, the basement floor is an easy one. We said, all right, I know we're going to have to insulate under the basement floor, so we started with R10. And we looked down the list of the report from HOT 2000 and said, okay, well, that's a pretty big number. We're still losing a fair amount of energy through the basement floor. It'd be pretty easy to fix that. So we doubled that to R20, and then we said, okay, that's going to cost about say $700. It's going to save, and I'm sorry, I can't remember the numbers 100% here, but it's going to save X number of kilowatt hours a year. So to save those kilowatt hours a year, it costs us only $4 a kilowatt hour a year. So that's cheaper than PV, so we'll do it. And we did that with every element of the house, and that way we knew we weren't spending too much in one area and not enough in another, and that we had a number down. It wasn't as low as we wanted, but it was a number we could live with. And it's a key ingredient if you're serious about getting to net zero. And then just a couple of things that are too important not to repeat many times. One of them is air tightness. You'll find in the modeling that you're going to have to take a guess at what that air tightness is. You really want to think about choosing a wall system that's going to let you get a very airtight house. Nothing you can do has a better payback than air tightness. Just if you play with the HOT 2000 model, if in our Riverdale house we were to have said, okay, well, we can live with 1.5 air changes an hour, pretty tight house. It would have cost us 1,300 kilowatt hours a year more than if we could get it down to 0.5. Which was our target. And so if you multiply that by 7, it's going to take $9,000 worth of photovoltaic panels to replace that capacity if we had the room. So it's just never underestimate the importance of that, and really start thinking about it from day one. You know, after a certain period of time and after a certain number of these, you'll probably end up not having to go through that detailed optimization process every time. And my guess is that if you're going to skip that step, if you're expecting to get to net zero, you should be aiming at insulation values and air tightness values in this sort of range. And you can see how they compare with typical R values. You can do a little faster if you start somewhere in that range and then and not go through quite so many iterations as we did. So the next step then, we've optimized the envelope. We've got a new total amount of energy that the house is using from HOT 2000, and now we want to turn our attention, before we go too much further, to optimizing passive solar, because that's the first most economical renewable energy there is. So we want to maximize it. We're going to have to add thermal mass, and we want to make sure we're not going to have an overheating problem. This is an area where HOT 2000 gives a fairly sort of clunky result. It models on a week-by-week or month-by-month basis and not an hour-by-hour basis. But it will tell you if there's overheating by telling you what the air conditioning load would be if you enable that function. So there are some. We'll talk about overhangs in a second, but I always check HOT 2000 first to see whether it's likely we've got some overheating. So in the Riverdale project, we ended up with about 35% of our total space heating needs coming through our south-facing windows. We added a small amount of mass, probably not quite enough. But it was there that I learned that being there on March open houses when it was 20 below outside. I'd look out the window, and our overhang that was designed to, according to the sort of classic rule of thumb that you'd shade the sun completely on June 21st, was cutting off about 1/3 of the window that we could have used that day because it was minus 25 out. And then in August, I was noticing that only about 2/3 of it was covered because the sun had dropped down lower and was now coming more directly into the window. So an awning is probably better. And